Hi, Michael.
Hey, Charles. How's it going?
It's going quite well. How's it going with you?
Good, good.
Good, good. So today, I thought we would talk a little bit about the philosophy of machine learning.
Ooh, I hate philosophy.
I don't like it much either, although I'm a doctor of philosophy.
Oh, that's very impressive.
Aren't you a doctor of philosophy too?
I am. It's kind of impressive.
It is kind of impressive. So what we wanted to kind of get across today was a little bit about why the class is structured the way it is, what the different parts are, and maybe go a little bit of back and forth about what we think you should be getting out of the course. That seem reasonable?
Sure.
Okay. Well, so first off, by the way, before we get started, I wanted to thank you for coming down to Atlanta and joining me in these beautiful studios.
Well, it's very nice to be here. Thank you for inviting me.
Oh, no, no. Thank you for coming, Michael.
Thank you for asking me to do the course. This has been a lot of fun.
Oh, the whole point was to be able to do the course with you, Michael. We like each other, and that's one of the things that we want to get across in this class, because we like machine learning. We have a lot of stuff in common, but I'm not sure we completely agree on the most important parts of machine learning and why we do the things that we do.
All right.
So I think people in the outside world, Michael, would claim that you're more theoretical than I am.
In theory.
In theory, and I'm more practical than you are.
Practically.
At least in practice. And hopefully some of that tension will come out in the class. But I think in order to see why that tension works that way, you have to understand what machine learning is. So, Michael.
Right.
What's machine learning?
It's about proving theorems.
No.
No.
I would not say it's about proving theorems.
No.
Although, proving theorems is often important in machine learning.
I agree with that.
Okay.
So we're on the same page.
We're partially on the same page. What is machine learning?
What is machine learning?
Give me a definition.
So it is computational statistics. How's that for a definition?
That is a definition. It is wrong on so many levels. However, a lot of people would agree with that statement. They would say that machine learning is really just applied statistics.
Not applied statistics, computational statistics.
Computationally applied statistics. I don't like that definition. I think that it's a bit too narrow. I think that machine learning is about this broader notion of building artifacts, computational artifacts typically, that learn over time based on experience. And then in particular, it's not just the act of building these artifacts that matter, it's the math behind it, it's the science behind it, it's the engineering behind it, and it's the computing behind it. It's everything that goes into building intelligent artifacts that almost by necessity have to learn over time. You buy that?
Yeah, so you have data, and you do analysis of the data and try to glean things from the data and use various kinds of computational structure to do that. So, computational statistics.
I don't think that's computational statistics.